Hey everybody and welcome back. This is an In-Situ Resource Utilization project. In other words, it is made with the things I already have lying around. Not a great success, frankly, but take it for the sake of fun. So I have to mow a large lawn, about 1500 square meters. There is a problem. This lawn is literally covered with bramble, any kind of weeds, many of them with large stems. It's impossible to regular lawnmower. The only option is to use a machine that have in front that is like similar to an Haze trimmer. So I went with the idea to use an actual electric Haze trimmer. I have a problem actually. I don't have a long enough extension cord. And in place of the long extension cord, batteries can be used. It happens that I have two old still working batteries. Batteries have 12 volts. Put them together in series at maximum provide 24 volts. It is about 10 times lower than the Haze trimmer, that is 230 volt AC. Batteries provide DC. Definitely the voltage not enough. But there is a solution. And the solution is to use an inverter that accepts DC voltage and input, 24 volts, and provides an output 230 volts AC. So my idea is to make a portable source of energy at which accessories, in this case the Haze trimmer, can be attached to. Basically a cart that will carry all these things together. After having cut the various elements required, the frame that will become the chassis of the cart is welded. The next part to be welded is the bracket that will hold the Haze trimmer. About this part, at first I thought to exploit the screws that hold the bottom cover of the trimmer's motor, but after having checked them, I concluded that the arrangement would have been too flimsy, so I defaulted into the idea of a bracket. And this will become the jack holder that will keep the cart on rest. This project should not be just a tool to mow wild vegetation, so I focused on flexibility, and a portable silent source of energy is a nice asset to have too. This is the wheel's axle, where a large washer will work as top flange for the wheel. And a final cleanup makes the parts nice and tidy. Here the frame of the cart is ready, and before welding the axle of the wheels for the wheels, I have to make 4 holes to fix a piece of plywood that will hold the batteries in place, and this is the bracket that will hold the Haze trimmer. Okay, these tapped holes are not the best expression of accuracy. Well, I changed my mind, and instead of using a piece of plywood to hold batteries, I thought to use this transverse to both support and hold the batteries at the same time. Of the construction process, measurements take me more time than anything else, and still mistakes often happen. With a 40 by 4 mm flat bar, the bottom side of this upside-down T is welded. This will be the central support between the two batteries, Another 20 by 4 mm bar is also welded to complete the T and will become the divisor between the two batteries. Only a few millimeters of gap are left, so this work must be decently precise. Now it's time to weld the axle for the wheels. It must be positioned exactly parallel and slightly off-center to the bar center toward the jack. So I started with a single small point weld, then the axle is adjusted to be exactly parallel and a second spot is welded on the other side. Measurements are double-checked because as long as there are just small spots welded, it is easier to remove the weld and make the adjustments in case something went wrong. In this case, the axle is correctly in place, so can be firmly welded. Even the jack holder is welded at the middle below the cart. So here where the batteries go, and here the inverter will be placed here, and so I need the bracket to keep the inverter in place, and the bracket must have a point where a clamp will be fixed to keep the batteries in place. So let's make the bracket. The inverter needs to be kept vertical to help the air flowing along its heat sink. The bracket is made using square tube, 20 by 20 mm in size and 2 mm thick. 4 holes are drilled on the tubes, and those holes are tapped to carry 4 mm screws that will secure the inverter on the bracket. Again, after having welded a couple of spots, the parallelism is checked before the final welding is carried on. The bracket is then welded to the cart, and yeah, welding on the flank of the tube is easier than on the edge. Okay, to hold the Haze trimmer, I've made this T thing, and that will go below here. Then I reclaim this this scrap piece of steel that will go here, and these two things that will all hold the Haze trimmer on the arm of the T. Sorry for the confusion. This part needs to be bended. Let's bend it on the press. This key, it was of my father, and I recovered it. Hello. Too close. That could be better, but I think they work. These are the plates that will hold the bracket that in turn will hold the Haze trimmer. So this is the holder of the Haze trimmer, and the Haze trimmer will be place it here like this, this way. And because the motor of the Haze trimmer obviously don't cut anything, we need to keep this at an angle to reduce the footprint that the motor will have on the path of the lane that will be cut on the lawn. So the way to do this is to keep this at an angle like this, and I need to make a bracket that with a flange that will be attached to the cart, and I have to be careful that the wheel don't touch the whole thing. Not for highway use. This angle is correct, so let's make it. The flange is welded at the required angle to the T-bracket, and the piece of steel is welded below as well for stiffness. Then with the angle grinder I've cut it to the proper shape, but sorry, I forgot to turn on the camera. A second flange is now welded to the cart using the Haze trimmer holder as a reference. And even this flange is stiffened using these two wedges. A couple of tubes made flat on one end with a press are welded to the cart. They will accept the handle. A nut is then rounded up to make the tip of the jack, into which a threaded feet will be screwed in. And the feet is made using two washers and a screw welded together. Because the welding bead was too close to one of the holes, I had to mill it to make room for the screw. Well, it's time to make some wiring, so let's have a look at the schematic. This is the schematic. It's pretty simple. We have the two batteries, 12 volts each, that are connected in series through this cable and this in switch. This actually a sectioner, and this fuse that protect the circuit from if anything goes wrong here. And the two batteries connected in series will give us 24 volt that will power the inverter. Here we have the inverter, 24 volts DC in input and 230 volt AC in output, and at the power outlet of the inverter we connect a plug with a cable that will go to a switch, and this switch is a self-releasing switch, so you have to keep it pushed down to power the hedge trimmer, and this is a safety feature that is really important. And here the plug where the hedge trimmer will be connected. From the cables, the yellow-green wire is cut because the hedge trimmer, being double insulated, don't need it. This plastic box will host the switch. I've cut this with a knife, and the switch fit in perfectly. I need something to keep it in place, and I salvaged this switch, this push switch, from an old electric tool, and as you can see, it closes the circuit when the button is kept pushed down. To hold in place the push button, I've made this simple clamp out of mild steel and blackened with heat and oil. This handle was salvaged from an old lawnmower. It's time to assemble the various parts. First, the contour box on the handle. Then the wheels, making sure that the axle is well lubricated with grease. You will notice the paint is not applied to the section that goes inside the wheel, where the rollers inside the wheel's hub need to run freely. A washer and a cotter pin complete the assembly of the wheel. Here the jack is inserted into its holder and the linch pin is used to stop the jack in place. Even this pin is blackened with heat and oil, and the jack is completed with a threaded feet. On the two tubes welded on the sides, a couple of extension tubes are inserted. This strap is made with a chunk of electric wire and will prevent the linch pin to be lost. The ends are terminated with a chunk of heat-shrinking sleeve. It's time to install the batteries and to connect the ground wire to the inverter. To damp vibrations, the inverter is fixed through rubber dampers. They are made using high-density adhesive sponge and a rubber hose, the same used in gardening. Our circuit requires a fuse and a disconnecting sectioner. To make this from a scrap board of bakelite, I cut off this smaller board. The bracket is used to hold the board, and the other holes are used to make the nodes of the circuit. On top, a piece of aluminum bar creates the contact between the fuse and the sectioner. The fuse is rated 100 ampere. The sectioner is made using the same aluminum flat bar with an eye on the side to allow it to pivot and an open eyelet on the other side. The thick wires are required to carry the current from the batteries to the inverter. This comes from the fact that power output from the inverter plus losses due to efficiency is the one the batteries see too, but a lower voltage. And because power is the product of current by voltage, given an estimated power of 1300 watts divided by 24 volts gives 54 ampere. At a density of 4 amps per square millimeter, the wires should have a section of 14 millimeter or a diameter of 4.5 millimeter. That's why wires are that thick. After having installed the handle, it's time to look at the Haze trimmer. Since it has its own switch that can be operated when using in this application, I forced the switch to stay on using a couple of zip ties. The very first test, the disconnecting section is closed to connect the circuit, the plug inserted into the power outlet of the inverter, and the inverter turned on. Oh yeah! Finally, the head trimmer is fixed onto its holder through the 3 clamps, 2 on the sides and 1 on the back. Then it is attached to the cart with a couple of bolts. The flange allows to change the angle, while the other flange can be used for multiple purposes.
Okay, this kind of work, but it is too heavy.
I was aware of this potential problem, and my original idea was to add a propelling motor in place of the jack, but I discovered the motor I thought to use needs to be repaired and wasn't possible to use it. So I made a boom to hold the Haze trimmer and used the cart just a power source. After having added a strap to carry the trimmer, it worked decently and allowed me to clean up a large chunk of land. Even though as an electric scythe was difficult to use, mostly because the uneven land I have, still it remains useful as a silent portable source of energy, able to provide up to 1 kilowatt at mains voltage. It can be useful on a construction site or to power tools when the power grid is not available, particularly when relatively small electric tools are used discontinuously, such as a painted mixer or an air compressor, getting rid of the noise and smoke a power generator makes. Do you like the video? Click on the thumb up icon and share. I don't post videos on a regular pace, so if you don't want to miss any video, consider to subscribe and click the bell icon. Otherwise, YouTube won't notify you when new videos are uploaded. Thanks for watching, see you next time, bye!